Hello folks, and welcome to Advent of Code. This is day number 11, and I'm really excited to be doing this with you all. So, today we're not yet at the weekend. This is a Thursday night, does that sound right? Yeah, so I expect kind of one moderate difficulty puzzle today, using a little bit of algorithms, and then we are headed into the weekend, where there's going to be a little bit more intensive of stuff going on. So, we are about to land in another airport, so I'm assuming that the next puzzle is going to be some kind of airport theme. So let's go ahead and prepare an input file, and let's see where we're at with the puzzle. So, also need to make a file for day 11 for the code. And yeah, I have literally no idea what's coming in this puzzle, aside from a little bit of algorithms now that Eric seems to be willing to throw in a little bit of algorithms. So yesterday, if you recall, we used memoization, and today I suspect there might be something involving a search. Hello, Lala. How are you doing? Cool. So I am basically in a holding pattern, waiting for the puzzle to drop. Just quickly get that set up. Hope everyone is having a good day. For those of you who are doing Advent of Code on your own, good luck to you, and I hope that you do well today. I hope that that you don't have any weird errors or weird algorithms bugs. So let's go ahead and get ready to do the puzzle. I'm going to really quickly go and get a drink of water while I'm waiting. All right. Important to stay hydrated. One of the things that came up on the stream yesterday after we ended the stream and I went and raided a bunch of other people is that if you are frantically making like one change at a time because you're like, oh, it's just this one other thing, like you gotta sit, you gotta pause, you gotta breathe, like, you know, breathe, take some water. So I'm taking that to heart by having my water close at hand today. All right. Another interesting question is, I suspect maybe we'll have a mid-flight puzzle for day 12, and then we'll actually land on the island. That'll be exciting too. So we'll see what happens with that. Thank you, THFYM. Appreciate the wishes of good luck. All right, let's see what this is. There's a ferry. No one is there. Floor, empty seat, or occupied seat. Okay, this is a state machine. Yep. Okay, so this is fair enough. This is literally just a state machine with 3 states. All right. So day 11, simple. So we're going to paste this in here. Let's grab our real input as well, which is considerably bigger, but that's fine. All right, that looks like a whole input to me. It is 100 by 100 or 99 by 99, something like that. That makes sense. Okay, we do not need strconv. And literally for each character in here, we're just saying, okay, so we're going to set this up. I'm going to set this up just as a map of pair to location. So type chord struct row call int, and then chord is going to be make map from chord to bool. And then for, this is going to be row, C, V in range S, switch C, case L. So I'm going to say available. is going to be this. So available of chord RC is going to be true case. Hypothetically, if it's a hash, that means it's occupied, but I don't think this case is utilized here, but we're going to explicitly set it. And then in the other case, which is going to be, if it's just a dot, I want to make sure that there's nothing there. I'm just denoting here what my conventions are, even though this map should start out not populated. Okay, great. So let's make sure that we have this working correctly. So I'll just run it. This is actually just like that. Okay. All right, and where is Victor get used? Oh, whoops. There we go. Victor for value. Okay, so that makes sense. All seats are based off of for each seat simultaneously. Okay, so that's easy enough. So we're going to do it this way. Okay. So how many rounds am I asked to evaluate? Until no seats change. Okay. 4. So we're just going to execute this indefinitely. So we're going to retain what the previous state was. So AV in range available. So let's see. Prev is make app chord bool, same as before. Prev k equals v is pretty straightforward. Okay. Now, and now we want to for v in range available. If v is false, occupied plus, and we print occupied. Okay. So that's how we get the final answer. So here, k in range available. So if the seat is empty and there are no occupied seats adjacent to it, then the seat becomes occupied. Okay. Let's do it this way, actually, that's better. Okay. If v, so if it's available, then, and there are no occupied next to it. Actually, so I need to switch available to occupied, because I think that'll make my life easier. Okay, and now this makes this simpler. Let's have to think this through. Yeah, so what's going on here is we're being asked to evaluate a state machine, kind of similar to Game of Life, if you've seen Game of Life before. So it's pretty similar to that. So that's what's happening here. Okay. The other thing that needs to happen here is this is true and this is false. Okay. Great. So if it is occupied and 4 or more seats adjacent to it are occupied, then the seat becomes empty. Let's just do it this way. So we're just going to do it this way. Okay. This one, including diagonal, actually. Diagonal is allowed, so that should be 8. Okay, great. So in fact, then we need to do this slightly differently, which is fine. Going to do it this way instead. That'll make my life easier. Same deal here, except for it's C offset instead of R offset. Hey Eric, how are you doing? If C offset equals 0 and R offset is 0, continue, make otherwise, ret equals append of ret chord C row plus R offset C col plus C offset. Okay, let's just clean this up. All right, now for here, now we need to define this. So I'm going to need this in 2 different places, so I may as well define it now. Func C chord count occupied neighbors. Map from chord to bool, returns an integer. So, for in range C adjacent, all right, so if occupied n, then count plus plus. Okay. Now we can tackle this a little bit more easily. All right. If that is greater than or equal to 4, then we set occupied of k to false. If not occupied, if there are no occupied seats adjacent to it, then it becomes occupied. Otherwise, the state does not change. We're already just leaving that alone. We're just using the previous thing to work around with that, so that's fine. Okay. Let's test on this small input. There are... Whoa, that's not right. Something is wrong here. Oh, I forgot to put a break here, of course. So change false. I was like, why is this infinite looping? If not changed, That should do it. Okay, 37 seats end up occupied in that scenario. Now we run it on my real input. And 2470, so let's go ahead and feed it to here. That's correct, rank 325. What am I doing getting in the top 500? I don't understand. That felt slow to me. Okay, as soon as people start to arrive, people just care about the first seat that they see. Empty seat would... See, what?
It says cap capacity 2160.
Would see...
Yeah.
Okay. All right, so this is the part B logic, which is slightly different. So now we have it. So, okay, this is basically the same, except for our rules have changed. So this is the first time where I'm going to add the flag for is this part B or not. Whether to use part B logic. Okay. So if not part B, then we do this. All right. Otherwise, we need to have a new algorithm. So it takes 5 or more occupied seats for an occupied seat to be empty, and it's seeing occupied seats throughout the first seat in any direction. Okay, that's fine. So wait, that's not correct. That logic is still the same. I was mutating the wrong thing there. The thing that needs part B logic is here. So let's see. Now takes 5 rather than 4. If part B, then occupy threshold is actually 5. Right, that should do it. And over here, the other change is occupied neighbors is now different. So let's see, that still is the same, except for the difference is now here. If part B, if not part B, then we do this. Otherwise, we need to do something else. Do I have a repo? My repo is github.com/LizTheGray. So advent of code, tree main 2020, I think, something like that. All right, let's just make sure I didn't break anything. So, yep, this still yields the previous results. So the only thing that I need to change here is so see. So I need to get past my occupied map here. That's the other difference. So we're going to do that. Okay. If seat then pause let's see. So pause equals, so instead of that being like this, it's going to look like this. And if at any point we go off the edge of the map, then we know that we are done. So if pause col is less than 0, pause row is less than 0, or pause. We need the min and max coordinates as well. In this case, I happen to know it's 100, so I'm just going to do this really sneakily, and then I'll fix it up later. Hey Vex, how are you doing? Is greater than 99, 100, or pause row is greater than 100, and we can just break out and say we're done. All right, I think that should do it. Oh, whoops. There we go. Line 28, what's that? Oh, that just needs to be something like that. Okay. 2470. So what's happening here? Oh, I bet the problem is I am repeatedly evaluating where I need to memoize where these things go. But let's check that it works in the small file first. I don't think I'm breaking. I think that's my problem here. Oh. Let's see. So if I see I see the problem. No, this breaks out of here. That's fine. So we need to pick each direction. We travel in that direction. That's fine so far. If it's not a seat, yeah, this should be okay. Let's just make sure that I understand properly what's happening here. Am I a competitive programmer? Kind of. This is an educational stream, so I do aim to educate about what I'm doing along the way. But I do try to aim to finish roughly in the top 500 to 1,000 on the more complex problems. On the simpler problems, because I'm explaining to you along the way, right? Like you'll notice I'm not typing right now. I'm not even thinking about the puzzle, right? Like that does slow me down if it's a simpler problem. But you know, 5 minutes here and there explaining what I'm doing actually does speed me up on the more complex problems. Okay. So let's see. That seems fine. Is it possible that I'm just I'm wondering how bad is this? What? It's not even getting to here? That's fascinating. really curious. What happens here? Okay, so... Oh, now I feel very silly. This needs to start from 1. Oh, I feel very silly. Okay. That's better. So now there are 26 occupied seats. So now let's run it here. 2259. I bet that is it. I'm done. Rank 428. So yeah. Okay. Let me just tidy this code up a little bit. But I think that I think that does that quite nicely. Let's see what the calendar looks like. Ooh, there's some kind of thing on the boat. Cool. What do we do here? I think the only thing I need to do here is, you know what, actually the complexity here of going up to 100 times for the simple versus complex, I'm not going to worry about it. That's fine. Okay. So to recap the strategy and what I did, so what I did is I wrote a type to handle kind of, you know, parsing the row and columns. So I'm using a map of coordinates in Golang. So if there's an entry in the map, it's a valid seat. And if it's true, then it's occupied. If it's false, then it's a empty seat. And if it's not present, nil, then it means that there is no valid seat at that position. So my adjacency thing is pretty simple here. For part A, you just go plus or minus 1 in each of the x and y coordinates, ignoring going by 0 initially. And if you So if you are not if you're not traversing by x or y, you're just staying in the same place. But otherwise, we check the adjacent seats around you. But for part B, we need to keep on looking until in a direction until we find a seat that you can see, because there may be a seat that is further away that is within line of sight of you. So that's what this logic here was doing. I just had this bad initial number here of 1. Instead of 0 instead of 1, that caused me to look at the same seat rather than looking, 1 this way and then 1 that way and then 1 that way and so forth. So I return a list of seats at positions, or if there is not a seat at a position, I just ignore it. And then I just count how many neighbors there are that have occupied seats. And then this is a fairly straightforward state machine where we are attempting to determine what the pattern is. I'm actually kind of curious to print out the pattern at each step, but on the other hand, this has kind of been done for us to a degree, so I'm not going to worry too much about it. So yeah, that was today's puzzle, which I'm pretty happy with how I solved it, so I'm just going to check it in, and then you can have a look at it in my repo. Day 11 AB solution. And we'll go ahead and push it up. So you can see this code now at github.com /Liz advent of code if you're interested in seeing more. Eric is actually in this chat, so you can just ask him directly. He also does a recap stream typically at the end of Advent of Code, where he talks about kind of what he found super interesting about how he put the puzzles together. Cool. Let's go ahead and raid someone who is still running. Let's see. Viwu is going. Let's go ahead and send Viwu some folks. Cheers, folks. Thanks for watching. See you tomorrow for the second set of weekend puzzles.